Welcome to AS Level Chemistry, Theme 1.1, Atoms, Molecules, and Stoichiometry. This topic is the foundation of chemistry. By the end, you'll understand relative mass, the mole, empirical and molecular formulas, and key calculations. Let's begin. Relative mass. First, let's talk about relative mass. Atomic mass, AR, is the weighted average mass of an atom compared to carbon-12. Molecular mass, MR, is the total mass of a molecule. Formula mass is the mass of one formula unit of an ionic compound. An isotopic mass is the mass of a particular isotope of an element. All of these are compared to carbon-12, where one atom of carbon-12 is defined as exactly 12 units of mass. One unified atomic mass unit, symbol U, equals 1.66 times 10 to the power negative 27 kilograms. Exam tip. Remember, AR values on the periodic table are averages because most elements exist as a mixture of isotopes. The mole. Now, let's move to the idea of the mole. A mole is the amount of substance that contains 6.02 times 10 to the power 23 particles. This number is called Avogadro's constant. These particles can be atoms, ions, molecules, or even electrons. That's a mind-blowing number. Imagine 602 sextillion particles, all in just one mole. Worked example. Question: how many atoms are there in 2 moles of sodium? Step 1. Recall that 1 mole has Avogadro's number of atoms, which is 6.02 times 10 to the power 23. Step 2. Multiply by 2. Final answer: 1.204 times 10 to the power 24 atoms of sodium. Exam tip. Always check whether the question asks for atoms, molecules, or ions. It's easy to lose marks by forgetting this. Mass spectra. We can measure isotope abundances using a mass spectrum. Relative abundance is calculated as peak height divided by total height multiplied by 100%. Relative atomic mass, AR, is then calculated by multiplying each isotope's mass by its abundance, adding them up, and dividing by 100. Worked example. Suppose chlorine has 2 isotopes, chlorine 35 with 75% abundance and chlorine 37 with 25% abundance. Step 1. Multiply 35 by 75. That's 2,625. Step 2. Multiply 37 by 25. That's 925. Step 3. Add them. 3,550. Step 4. Divide by 100. Final answer: relative atomic mass equals 35.5. Exam tip. When you see mass spectra, examiners love to test whether you know how to calculate AR. Don't forget to divide by 100 at the end. Empirical and molecular formulae. Next, let's talk about formulas. The empirical formula gives the simplest whole number ratio of atoms in a compound. The molecular formula shows the actual number of atoms. You can calculate the molecular formula using this relationship. Molecular formula equals empirical formula multiplied by N, where N equals the molecular mass divided by the empirical formula mass. Worked example. A hydrocarbon has empirical formula, CH2, and a relative molecular mass of 56. Step 1. Calculate the empirical formula mass. C is 12, plus 2 hydrogens is 14. Step 2. Divide molecular mass by empirical mass. 56 divided by 14 equals 4. Step 3. Multiply empirical formula by 4. Final answer: molecular formula is C4 height. Exam tip. Examiners often test empirical formula from experimental data. Always convert masses to moles before simplifying ratios. Calculations with the mole concept. Now let's practice some mole calculations. Number of moles equals mass divided by molar mass. For gases, volume equals moles times 24 at room temperature and pressure. And concentration equals moles divided by volume with the unit mole per dm cubed. Worked example 1. How many moles are there in 9 grams of water? Step 1. Molar mass of water is 18. Step 2. Divide mass by molar mass. 9 divided by 18 equals 0.5. Final answer: 0.5 moles. Worked example 2. What is the concentration of 0.1 mole of sodium hydroxide in 250 cm cubed of solution? Step 1. Convert volume. 250 cm cubed equals 0.250 dm cubed. Step 2. Divide moles by volume. 0.1 divided by 0.250 equals 0.4. Final answer. Concentration is 0.4 mole per dm cubed. Exam tip. Always convert cm cubed to dm cubed. Forgetting this is a classic error students make in exams. Hydrated and anhydrous compounds. Finally, let's talk about hydrated and anhydrous compounds. An anhydrous compound has all water removed. A hydrated compound contains water molecules within its crystal structure. These are called water of crystallization. In exams, you may be asked to calculate the number of water molecules in a hydrated salt. Worked example. A sample of hydrated copper sulfate, CuSO4xH2O, has a mass of 250 grams when hydrated and 160 grams when anhydrous. Calculate X. Step 1. Mass of water lost equals 250 minus 160, which is 90 grams. Step 2. Moles of QSO4 equals 160 divided by 160, which is 1 mole. Step 3. Moles of water equals 90 divided by 18, which is 5. Step 4. Ratio is 1 mole, QSO4 to 5 moles, H2O. Final answer. The formula is QSO45H2O. Exam tip. In water of crystallization questions, always find the mass of water lost by subtraction. Closing recap. So in this chapter, we've covered relative mass, the mole and Avogadro's constant, how to interpret mass spectra, empirical and molecular formulas, mole calculations, and water of crystallization. These skills are not just theory, they are tested in almost every AS exam paper. Practice them often, and remember the exam tips we discussed. In the next chapter, we'll build on these foundations with atomic structure. Let's continue.